Python, machine learning, large language models, LangChain, vector databases, agents, speech, evaluation, deployment. An AI roadmap can quickly become a wall of tools with no clear starting point. The solution is not to learn everything at once. It is to learn in dependency order and prove each stage with something that works. In this video, I will show you the exact path used in this series, what each phase unlocks, and the project that tells you when you are ready to move forward. The common mistake is measuring progress by tutorials completed. That creates familiarity. But familiarity is not engineering. You may recognize every term and still be unable to turn a blank folder into a dependable application. Use a different loop. Understand one concept. Build the smallest useful system. Test its normal path and its failure path. Explain what happened in plain language. Then improve one weakness. Every module in this series follows that loop. You do not need perfect theory before building, and you should not keep building without understanding what your system is doing. Phase 1 is Foundations and Python. First, understand the job. AI engineering is not only model training. It is the work of combining data, models, software, evaluation, and operational safeguards into a useful system. Then learn enough Python to control that system, variables, functions, modules, collections, exceptions, files, virtual environments, packages, APIs, and basic testing. You do not need to become a language expert before continuing. You do need to read a traceback, inspect data, change a function, and verify the result. Your checkpoint is a small local application with a clear input and output. Our first ticket router already demonstrates that idea. If you can run it, change it, test it, and explain its limitations, Phase 1 is doing its job. Phase 2 explains how machines work with language. Start with text processing, tokenization, features, labels, training data, and evaluation. Classic, natural language processing is still useful because it makes the mechanics visible. It also teaches an important lesson. The quality of a model cannot rescue unclear labels or misleading data. Next, study large language model fundamentals. Learn what tokens, context windows, prompts, temperature, structured output, and model limitations actually mean. Separate fluent language from verified truth. A confident answer can still be wrong. The checkpoint is not a clever prompt. It is a small text system with a defined contract, a repeatable test set, and examples of failure. You should be able to explain why you selected the model and how you will detect a bad result. Phase 3 is where isolated model calls become applications. LangChain helps you connect prompts, models, tools, retrievers, structured outputs, and reusable components. Learn the framework as orchestration, not as magic. You should still understand the request sent to the model and the value returned by every step. Vector databases introduce semantic search. Documents are split into useful chunks. Embeddings represent their meaning, and retrieval selects evidence for a question. Combined with a language model, this becomes retrieval augmented generation. The difficult work is not drawing the architecture. It is choosing good chunks, attaching reliable metadata, measuring retrieval, and refusing to answer when the evidence is weak. The LangChain graph framework adds explicit state and controlled branching for workflows that need multiple steps. Use it when the process genuinely needs retries, tools, checkpoints, or human approval. Do not turn a simple request into an agent just because agents are popular. Your checkpoint is an evidence-grounded assistant. Show the retrieved sources, test questions with and without an answer, and include a safe path when the system is uncertain. Phase 4 expands the interface and hardens the system. Speech recognition and voice output teach you to handle audio, timing, transcription errors, streaming, and the extra latency of a real conversation. The model is only one component in that experience. Then move into production engineering. Track quality, latency, token usage, and cost. Version prompts and datasets. Log enough to debug failures without exposing private information. Add timeouts, retries, access controls, and clear ownership for human review. Evaluation must continue after launch because users and data will change. Responsible AI belongs inside this phase, not in a final disclaimer. Ask whose data was used, who can be harmed by an error, whether the decision can be challenged, and what happens when the system does not know. Your checkpoint is a capstone that another person can run, inspect, evaluate, and safely stop. A portfolio is not a gallery of screenshots. Each project should prove a different engineering capability, include a clear problem, an architecture you can defend, instructions that work, representative tests, an evaluation result, and known limitations. 5 focused projects are stronger than 20 copied demos. A useful sequence is 1 deterministic Python utility, 1 text classifier, 1 structured model application, 1 retrieval augmented generation system, and 1 controlled multi-step workflow. Your capstone can combine them, but each component should remain observable. During an interview, be ready to explain one failure in detail. What input broke the system? Which stage failed? What evidence did you collect? What trade-off did the fix introduce? That explanation demonstrates engineering judgment better than a long list of libraries. Keep the weekly rhythm simple. Spend the first part learning one concept. Spend the largest block building. Reserve time for tests and failure cases. And by publishing what you learned in a README, short technical note, or demonstration. If a topic takes longer, keep the order and reduce the scope. Do not skip testing to protect an imaginary schedule. Also avoid changing your entire stack every week. Repetition creates speed. Use a stable set of tools long enough to notice the patterns beneath them. At the end of each month, revisit an older project. Improve its data, evaluation, or safety path. That is where disconnected lessons become durable engineering skill. That is the roadmap. Foundations in Python, language data, model fundamentals, connected AI applications, speech, production engineering, and responsible AI. Move forward when you can build, test, and explain, not when a playlist reaches 100%. In the next video, we will compare human intelligence and machine intelligence and identify what current systems actually do well. Follow the series, build each checkpoint, and keep the evidence. Like this video and subscribe to AI Sandbox for more similar content.